Hello and welcome. You are watching the Algebra 1-2 Chapter 1 review. This contains the assignment, Chapter 1 closure, and all of those problems on there. So as you see them, hopefully they make a little more sense than just the answer that you've already been provided. And you learn a little something new, or you reaffirm your understanding of it as you watch this. I'm going to start with problem number 83. We're going to use the order of operations to simplify all the following expressions, and then we're going to answer letter G here. All right, so A through D, we have some expressions here, and we have to basically evaluate them, shrink them down to one number. And in order to do that, we have to follow the order of operations. You've either seen this. Please excuse my dear Aunt Sally. P stands for parentheses. E stands for exponents. M is multiplication, D is division, A is addition, S is subtraction. And in this order, parentheses take the highest precedence, exponents are next, multiplication and division are on the same level, and addition and subtraction are the lowest tier, right here. So you've also probably seen it like gems. I've never seen it this way, but it's the same thing. Grouping, or parentheses, exponents, multiplication and division, subtraction and addition. I suppose they use that so it spells gems. But anyway, the idea is when I do this, I'm going to basically go through a checkmark system. Do I have parentheses? Okay, let's do everything within there first. And within parentheses, do I have some other stuff to do like multiplication before addition, etc. Once I'm done with parentheses, or if I don't have any, then I'm going to check on exponents. Which things are being raised to certain powers? All right, let's take care of that. And you'll see a big thing on exponents for answering part G here. Then there's multiplication and division. If I'm down to only multiplication and division, I'm just going to go left to right, literally. I don't want to go things in the right first that'll affect my answer. You'll see an example here. And then addition and subtraction are my lowest here. I will go left and right to there if that's all that I have left as well. Okay, so letter A, let's go ahead and get started on this. Now here's where you do it wrong, right? Here's not the right approach. 5 minus 2 is 3. 3 times 3 is 9. 9 squared is 81. That is the incorrect approach. That's going straight left to right, and you are not following the order of operations. Go ahead and try it in a calculator, and you won't get that answer. Or you might get that answer, but you'll have landed on it luckily, because that's not how we do this order of operations. First, I'm going to check on parentheses. There are none. Exponents are next. This 2 is an exponent. This says 3 squared, which means instead of doing 2 times 3 first, I'm going to do 3 squared first, and 3 squared is 9. So I'm going to rewrite this entire thing, but instead of 3 squared, I'm going to write 9. Multiplication, or exponents, check. Multiplication and division. So instead of going left to right, multiplication happens before subtraction. So I could say this has negative 2 times 9 and make it negative 18. That's fine, and put the 5 in front. What I think is probably safer, the safer approach is to do 5 minus and then do 2 times 9. Big reason is when you do when you're subtracting an exponent. But this becomes 5 minus 18, and 5 minus 18, in case you're having trouble with some of your addition, subtraction stuff, it's the opposite of 18 minus 5. 18 minus 5 is 13. So this is negative 13. Of course, you can use a calculator, I suppose. Well, not for problems like this. Well, you have to show your work for these kinds of problems anyway. But anyway, negative 13 is not 81, as you know. So this is a different answer. So that's using the order of operations correctly. Okay, part B. This says negative 2 quantity squared. Now in parentheses, it's asking, is there anything you can do in parentheses? No, but that doesn't mean get rid of the parentheses. This is super important because this says I am squaring the number negative 2, and squaring means multiplying a number by itself. So this becomes negative 2 times negative 2. And if you haven't seen the movie yet, it's called Stand and Deliver. Jaime Escalante says, a negative times a negative is a positive. Say it, and you'd say it over and over and over. Negative times a negative is a positive. Why? Well, just because it is. Accept it. Negative 2 times negative 2 is positive 4. And that's your answer. You're probably excited to go to D, saying, what's the difference? C, we have 18 divided by 3 times 6. Now, some people believe that in please excuse my dear Aunt Sally, order of operations, that multiplication comes before division. In other words, this is 1, 2, 3, 4, 5, and 6, and 3 is before 4, so multiplication comes first. So what some people do is they group 3 times 6, they make it 18, and 18 divided by 18 becomes 1. Problem is, multiplication doesn't come first. Multiplication and division are on the same precedence level. That's why people say gems, because they want to know that multiplication and division are here, subtraction and addition are on the same level here. So I'm actually going to divide first because I'm just running left to right. It's not that one is precedence over the other, it's that left to right is how it's going to be read. So 18 divided by 3 is 6, and 6 times 6 is 36. So as you can see, the answer is not 1, it's 36. All right, D, here we go. So negative 2 squared. Now, most people might think, oh, it's 4. I'm squaring negative 2. But think of this in one of two ways. Exponents comes before subtraction. So think of this as 0 minus 2 squared. This becomes 0 minus 4, which is negative 4. Okay, that's one way to think about it, because remember, I am subtracting 2 squared. I am not taking negative 2 and squaring it. These parentheses says I'm doing negative 2 times negative 2. This is 0 minus 2 times 2. So there is a difference there. That's one way to look at it. Another way to look at it, instead of 0 minus 2 squared, is it is negative 1 times 2 squared. And exponents come before multiplication. So 2 squared is 4, so this is negative 1 times 4, which is negative 4. Let me go ahead and answer G right now, just because we're on the subject. Why are your answers for parts B and D different? Well, the parentheses change everything. This time I'm squaring negative 2. This time I'm squaring 2 and taking the opposite of it. So however you want to say that, however the answer in the back says it, I guess is good enough. Okay, letter E here, I have parentheses that are grouped, so I'm going to do 5 minus 3 here, and here I'm going to do 5 plus 3. The parentheses apart makes this say 2 times 8, and 2 times 8 is 16. There's another way we could look at this. When we start doing polynomial multiplication and distribution, there's going to be another way that we multiply these guys together. But this isn't necessary if I can combine like terms and evaluate these first. This will be a lot easier. All right, letter F, 24 times 1/4. If you have some trouble with your fractions multiplying and such, this is also 24 over 1 times 1 over 4. And when we multiply straight across. So I'm going to do 24 times 1 and 1 times 4. Now I'm going to evaluate this before I figure out the negative 2 part. I'll do that in a second. 24 times 1 is 24. 1 times 4 is 4. 24 divided by 4 is 6. So now I have 6, and I'm going to divide negative 2 from 6, and that becomes negative 3. A positive divided by a negative is a negative. Negative 3, and that's it. Okay, number 84, we have these numbers of tiles based on figure number. We have to figure out the first and fifth figures on our paper as well. So it's all about finding a pattern. So in terms of this, from figure 2 to figure 3, it looks like this guy was added onto what figure 2 was, and so was this right here. And this pattern will repeat. Another one gets added on figure 4 from figure 3, and then another 2 get added to the side over here. So if I were to do figure 5, it would be the same thing. Now, this is not going to be a good looking drawing. I already promise you that. It's going to look pretty bad. So let's see, take a look at that. So here I have 1, 2, 3, 4 rows of 2. So here I'm going to have 1, 2, 3, 4, 5 rows of 2. And here I have 1, 2, 3 of these ones here. So I have 1, 2, 3, 4 of them here. So there's my figure 5. I added 2 more here, and I added 1 more here. Figure 1 is the figure 4 figure 2. So you have to think about what was added to make figure 2. Well, I added those 2, so I'm going to take them away. And I added this one here, so I'm going to take that away. So figure 1 is going to look like this right here. So let me go ahead and draw that. Kind of looks like, what state is that? Utah, I think. So there's figure 1. Okay, how many tiles are in each figure? Figure 1 has 5. I'm going to go ahead and write this like a table. It's going to be the easiest way for me to do this. Whoa! Let me do a line. That's a big line. Let me do a smaller line. I'm going to go ahead and make a table here by figure number and tile amount, or amount of tiles. Pardon me. So figure number, because this way we can, whoops, not 1. Because this way we can kind of compare things a little bit easier, and tile number, so tile amount. So figure 1 has 5 tiles. Figure 2 has 8 tiles. Figure 3 has 11 tiles. And you can probably start to see a pattern. You probably recognized it early on. We're adding 3 each time. Figure 4 has 14 tiles. Figure 5 has 17 tiles. And this will probably keep going. Describe how the pattern is changing. So I'm just going to type it because my handwriting here is pretty bad. The number of tiles is increasing by 3 each time. Increasing by 3 each time. So when I go up 1 figure number, I'm also getting another set of 3 more tiles, so to speak. Okay, how many tiles would the 6th figure tile have? The 10th figure? So think about 6. You're going to add another 3, right? So that'll be 20. Now to find 10, I could add 3 4 more times. However, think about that. I'm adding 3 4 more times. So I'm adding 3 times 4 more. So if I want to jump all the way to 10, I'd have to be adding 12 to this one. I'm going to get 32, right? 7 will have 23, 8 will have 26, 9 will have 29, 10 will have 32. Now there's another way to do it. Like, what if you want to do the 100th tile, etc.? What I would probably do is start from figure 1. In fact, I'd start from figure 0. If there was a figure 0, that would have 2 tiles, right? So if you start from the number 2, then I can add 3 a certain number of times. If I wanted to do the figure 100, I would add 3 100 times. That number is 302. Okay, we're going to look more at this kind of stuff. They're called rules. We're going to use this a little bit more later down the line. So that's just something that's important to note there. That's actually a really cool secret method. But think about what you say in your head, how many times you add it. Multiplication is nothing more than addition a certain number of times. Okay, moving on. Number 85, copy and complete each of the diamond problems. Well, they already copied for me. The pattern using the diamond problems is shown out right. So if you have 2 values, x and y, the top number is x times y, that's the product, and the bottom number is x plus y, that's the sum. So essentially, if you have these 2 on the left and right, you can multiply them. 9 times negative 9, that's negative 81. And when you add them, 9 plus negative 9 is also 9 minus 9, and that is 0. Very nice. Letter B, this time I have the product and the sum. Now to find the 2 numbers. So there is some trial and error involved in this, but this one actually is a little easier than most. But let me make sure I explain the process just in case you don't have this 0 on bottom. There are a lot less numbers that multiply to become negative 36 than there are numbers that add to become 0. In terms of integers. In fact, there's an infinite amount of integers that add to become 0. And that's going to be kind of the hint toward how to get this one right pretty quickly. But in terms of this, what I want to do is instead list factors of negative 36. One number will be positive, one number will be negative. So 36 and negative 1, 12 and negative 3, 18 and negative 2, 9 and negative 4, 6 and negative 6, and I think just the opposite effect if I did negative 36 and positive 1, negative 12 and positive 3, etc. But which 2 add to 0? Should I really do all this work, or should you notice that 6 and negative 6 are additive inverses of each other. What additive inverses mean are the positive and negative versions of numbers. When I add 6 with negative 6, I get 0. 4 and negative 4 are additive inverses of each other. So when you notice that your sum is 0 here, it's probably very easy for me to just notice these have to be the same number. One has to be the negative version of it. So 36 must be a perfect square. So 6 times 6 gives you 36. But if one of them is negative, so is this as well. Now the point about this is you start to list your factors and you check which one. Now let's say this wasn't 36. Let's say this number was 5, right? And then you'd have to, and your answers would be 9 and negative 4. But when it comes to listing my factors, because my sum is positive, I should only list this set of factors, not this set where the bigger number is negative. Why? Because my sum is positive. And if my sum is positive, then my bigger number would also have to be positive. So there's no reason I should be listing these ones out. These 5 are the only ones that should apply. And then this would be your answer. But of course, that one's not your answer. This one is 6 and negative 6, so I can move on. Okay, part C. I have negative 20 as my product of two numbers. One of the numbers is 4. So what's the other number? We take negative 20, divide 4, to get negative 5. That's what that other number is. Remember, 4 times negative 5 is negative 20. So the opposite effect goes divide 4 or negative 20 by 4. Now I have to add these two, 4 and negative 5. 4 plus negative 5 is the same as 4 minus 5. And you have trouble with that. That's the same as the opposite of 5 minus 4. 5 minus 4 is 1. So the opposite of that is negative 1. That's that value there. Another way some people do these is they say, what do I have to subtract to get to 0? You have to subtract 4. How much more do I have to take away? I have to take 1 more away. So those cancel out, and that's what's left. Okay, final one, D. This one's a little different because now you have fractions, and this time you have the sum, so you have to figure out what two numbers add up to become 1/2. So I'm going to put an X right there just so I can kind of create an equation. Let's use a different color to be unique. So this is X right here. So if I add X and 4/5, I'm getting 1/2. So if you think of this in terms of algebra, if you subtract 4/5 from both sides, X will equal 1/2 minus 4/5. So the question is, what is 1/2 minus 4/5? So now you have to work toward getting a common denominator. And I can't explain too much for it without the video going way too long. But common denominator is basically getting this number on the bottom the same. And it comes by multiplying your fractions by some number that will give you a common denominator. So without teaching you how to find the least common multiple, that number will be 10. If I multiplied 2 by 5 and 5 by 2, I will have the same number on bottom. Now the thing about this thing is I can't change the value of 1/2. Right? 1 divided by 2 is 0.5. I can't change that, so I can't just multiply the bottom by 5. I have to multiply the top by 5 as well. Why? Because 5 divided by 5 is 1. And if I multiply 1/2 by 1, I'm still getting 1/2. But I'm changing the way that this value is going to end up looking. Instead of looking like 1/2, it's going to look like 5/10. We've used some pizza slice analogies in class, and I hope that those ones made sense as well. Half of a pizza, 5 out of 10 slices is also half of a pizza, right? So that makes sense. Now 4/5, I'm multiplying the 5 by 2, so I also have to multiply the 4 by 2 as well. 4 times 2 is 8, 5 times 2 is 10. Again, for the same reason why I multiply this by 5/5, because this number is 1 and this number is 1. I can't change the value of 4/5. Now in the middle was subtraction, so I still have to subtract here. Now that you have a common denominator, they are compared evenly, so you can subtract 5 with 8, and this is all divided by 10. 5 minus 8 is -3. So your final answer there is -3/10 for X. That's what that X value was. You had to do a little bit of work there. Now in order to get the product on top, this is actually the easier part. All you have to do is multiply -3/10 with 4/5. Sounds like big numbers, but Negative 3 times 4. All you do is multiply straight across. Negative 3 times 4 is negative 12. 10 times 5 is 50. So it's negative 12 over 50. But this fraction can reduce. Okay, I can divide the top and bottom by 2. Again, same thing. It's dividing by 1, so I'm not changing the number, but I am changing the way that it looks. Negative 12 over 2 is negative 6. 50 over 2 is 25. And that's the smallest that it can reduce to. So that number is negative 6 over 25. And there's all of number 85. Okay, 86. This is probably the biggest, baddest, hardest one in this whole thing. Graph and fully describe the function y equals 2. This is times the square root of x minus 1 plus 3. Okay, now in terms of fully describing it, there are a couple things that you want to mention for this thing. Now, this is a square root function, so it doesn't really have a vertex, but it does have a starting point. You want to describe, first of all, what kind of graph it is. It's a square root graph. Now, square root graphs, if you remember, they look like half a sideways parabola. Here's a full sideways parabola. Half a sideways parabola, just looks like that. So you can describe it like that, half a parabola on its side. In fact, I do think that's what the answer thing in the key thing says. I think it says it's half a parabola on its side, literally. You also want to talk about whether it's going up or down, if it's going to the left or to the right as well, left versus right. And if you can, also talk about where it starts at. That's kind of like the vertex. Remember, if I have a parabola like this is the vertex. Well, this would also be the starting point of whatever your graph ends up being. We'll see that as well. And then if you want to talk about domain and range, that would be fantastic as well. So I won't type them out, so you're going to have to listen to what I say for it. Now, in terms of doing this, I actually need to get a calculator because I'm going to do a lot of decimal values just to help you out a little bit. But I really want you to understand how this thing works. Here you have x values. You're going to do some work, and then you get y values out, and then it becomes a coordinate pair, an xy coordinate pair. We can plot those points. Sometimes I might ask you to choose choose some negative values and then choose some positive values and choose 0 and everything like that. The problem is there are restrictions on square roots. And let me type this part out just in the corner right here. You cannot take the square root of a negative number. Okay, that is super important. Because, you'll notice that when you get your calculator, but if you're wondering, why am I getting domain error? Why am I getting domain error? Well, the domain of a square root function is whatever x value you choose, where you're then taking the square root of 0, that is going to be the smallest x value that you can choose. You can't choose anything smaller than that. For instance, let's say I chose negative 5. In my work, that's going to be 2 times the square root of, this will be negative 5 minus 1, that's negative 6. Then plus 3. 2 times the square root of negative 6. Okay, square root of negative 6. You go to your calculator. I type square root negative 6. You can't see this. Oh, I got domain error. Why? Because I took the square root of a negative number. So I know you haven't practiced this too much, but when it comes to using what are called inequalities, I'm going to say that I need this inside value, this x minus 1. I need this to be 0 or positive, meaning the inside number, when I subtract 1 from x, that number better be 0 or a positive number. So x minus 1 should be greater than or equal to 0. And if you treat this like an equation, if I add 1 to both sides, it's going to say x has to be greater than or equal to 1. So you see how that kind of matches up with other equations and kind of how this one is too. I'm going to only choose values now in my table that are 1 or greater, and I'll actually get values out. So when it comes to doing this table right here, I'll start at 1, and I can go up from there, 2, 3, 4, etc. Now I'll do all of these for you, so you see them 8, 9, and 10. I'm going to go up to 10 only because I think that's only as far as this thing goes. Maybe it goes to 9 only. But let's calculate a few of these. So x is your input, y is your output. You can put the work in the middle. I'm not going to do this for each one as far as work goes. I'm just going to start plugging things in after a while into my calculator and writing the work. So the work for the first one, I'm going to write 2 times the square root of 1, that's for x, minus 1, Then outside the square root is plus 3. So that's going to equal 2 times the square root of 0 plus 3. Square root of 0 is 0. You can actually take that square root. Otherwise, I wouldn't have chose the value 1. 0 times 2 is 0. 0 plus 3 is 3. So your value, your coordinate pair, ends up being 1, 3. And I can plot that point. If I have this scaled to so that this is 5 units away, this is negative 5 units away, I think. This is 5 units up. This is negative 5 units away right there. The point 1, 3 is right there. Okay, if I do 2 here, substitute that in for x, that'll be 2 minus 1, then plus 3. That becomes 2 times the square root of 1 plus 3. The square root of 1 is 1. 1 times 2 is 2. And 2 plus 3 is 3. Just kidding, it's 5. So that ends up becoming the point 2 comma 5. And you go over 2 and up 5 right there. And that's another point. Now here's where things are going to get interesting. I'm going to cut out some of the work. I'm not going to plug in 3. I'll just say that 3 minus 1 is 2. But now I'm going to do 2 times 3 minus 1, which is 2, plus 3. Now, the square root of 2 is not 1. It's some decimal, I think. I'm going to actually get the actual thing here. So I'm going to do 2 times the square root of 2 in my calculator. Then I'm going to do plus 3. Hang on. Getting some issues with the calculator here. Then I'm going to do plus 3, and I'm going to get, oops, I have to change it from math print to classic. 2 times the square root of 2 plus 3 gives me 5.82. 5.83. So this point is 3 comma 5.83. Now do the best you can with this. 5 is right here, 6 is right here. 0.83 it's a lot closer. Think about it in a realistic way. 5.5 is right in between. 5.75, 5 3/4, is 3/4 of the way up. So 5.83 is a little closer, a little higher up there. You want to make something pretty good. Otherwise, your thing won't end up being as accurate as you wish it would be. So there is 3 comma 5.83. And I would keep continuing with this the entire way through. I'd keep putting in more points. I'm going to do a few more with you, not the entire thing. Because otherwise, if I did the entire thing, I'd take up the entire day doing this. So this one is 2 times the square root of 4 minus 1, which is 3, plus 3. So now I have to do 2 times, let's see, how do I go back? Here we go. 2 times the square root of 3, whoops, 3 plus 3. That's 6.46. So this point is 4 comma 6.46. 6.46 is very close to 6.5. So when I go to 4, I'm basically going to be at 6.5. But I shouldn't go more than that half point right there. Anyway, I would keep going. So you'd find all the other decimal points. Now, what I would recommend that you do, though, is on the side, know that you're subtracting 1 each time. So this was 1 minus 1, which became 0. This is 2 minus 1, which became 1. This is the inside number that you're taking the square root of. What I would recommend that you would do at this point, I mean, not that you would do, you do as best as you can to graph this. But what I'm going to do is say, look at 5 minus 1. That's 4. 4 is a perfect square. 5 is not a perfect square. 6 is not a perfect square. 7 is not a perfect square. 8 is not a perfect square. 9, again, is a perfect square. If I had enough room here, I would look for perfect squares here. The reason is because when I take the square root of it, this will be 2 times the square root of 4 plus 3. The square root of 4 is 2. 2 times 2 is 4. 4 plus 3 is 7. So now I have a point that's 5 comma 7. Notice I'm landing on integers. That's pretty cool. That's probably what I want to do. Let's jump all the way down to 10. That's 2 times the square root of 10 minus 1, which is 9, plus 3. The square root of 9 is 3. 2 times 3 is 6. 6 plus 3 is 9. So there's another point on here that's 10 comma 9. So I can go all the way 6, 7, 8, 9, 10. It's kind of off the map a little bit. That's 7, so 8, 9. So there's another point that's way over here as well. So to save myself some time, I'm only plotting the integer points right there. And you can keep doing that kind of thing. Close enough. You can keep doing that kind of thing. Like, for instance, what's my next perfect square? Oh, it's 16. So what's the x value? It was 17, because 17 minus 1 gives you 16. And then there's 25. What's the next x value there? It was 26. Right? So those are points that I'd want to plug in. 17, 26, 37, because 37 minus 1 is 36. 50, because 50 minus 1 is 49. Notice I will get integer values for y if I use these values for x. Because this one will be 2 times the square root of 16, which is 4, plus 3, and that's 11. This will be 2 times the square root of 25, which is 5, plus 3, which is 13. So notice how this is jumping up each time. That's kind of cool. 2 times the square root of 36, which is 6, plus 3, which is 15. And 2 times the square root of 49, again, 50 minus 1, is 7, plus 3 is 17. So I'm getting integer points. Now the problem is I can't really graph them here unless I changed my scale. If I made this 10, 20, 30, 40, 50, etc., then I could do that. But I didn't. But anyway, choose the values that you will, right? I mean, I could have found all these other points and plotted them and such, but for the sake of time, I wanted to show you a pattern of what's really nice. Find your perfect squares that you know you can take the square root of. The only tricky part is you have to do one number higher than it because it's x minus 1, not just x. Okay, let's describe this function. Okay, first of all, it's a square root function. Let's see if I can bullet point a couple of these. Square root. A square root function looks like a parabola, a U shape. The only difference is I'd have to take that parabola and I'd have to turn it on its side, and then I'd have to erase half of it. See how it looks like half a parabola? Let me try that again. See how that looks like half a parabola right there? Kind of cool. Kind of cool. Now, if this is the vertex of that parabola, then the start of this thing is like that vertex of that parabola right there, as you can tell. So this thing, the starting point, that quote-unquote vertex, is the minimum x value because it doesn't go any more left, and it's the minimum y value because it doesn't go any more down. Remember, I couldn't choose 0 here. This isn't going to go down forever this way. It goes down, it goes to the right forever, and it goes up forever. You should draw an arrow there, but it doesn't keep going this way because 1 is the smallest value I could have chosen. We already checked that right here. If I chose 0, I'd be taking the square root of -1, and I can't do that. So this is the minimum value. So the min x is 1. The min y is 3. Why is that important? When I talk about which way it goes up. Y increases, and x increases. As it goes up and to the right, it becomes further positive for both x and y. But really, this is important for domain and range. Domain is the set of values for x that you can plug into an equation and you get a value out for y. Whenever you get inputs, you should be getting outputs back. So the question is, what is the domain of this function? What x values can I choose? What was the smallest one? That's important, looking at that minimum there. The minimum value was 1. X can be 1. It can be anything greater than 1. Just like we put earlier on, x can be greater than or equal to 1. That is my domain. Now it's not 1, 2, 3, 4. These points also work right here. Right? All of those points apply to my domain. It's not just the integer values. So x is anything greater than or equal to 1. You could describe that in words. You could say the domain is any x value that is 1 or greater. Right? You know how I get fancy with my lingo. The range are the set of y values that you can have on your graph. So take a look at this. The minimum y value is 3, and then it only goes up from there. So what y values will you find here? Values that are 3 and greater than 3. So that's my range. And again, you could say that in words as well. Other features of note. This has no symmetry. So although a parabola has a line of symmetry that goes down like that, this one is not symmetrical because it's only half a parabola. So it doesn't have symmetry. It continues to go to the right, as I said before. Gosh, what else? It curves, right? It's not a straight line, so square root function, curvy like that. I think that's kind of all that you got to say for this thing. I mean, we've hit a lot of points. Literally, no pun intended. We've hit a lot of points. So this was the biggest, baddest, hardest problem for sure. Want to make sure you had something involved with it. Okay, number 87, solve each equation. Check your solution. These are linear equations, and all linear equations can go by the same factotum. You do three things. You simplify each side of the equation, both the expressions on either side. You isolate your x term so that it's only on one side of the equation, and you divide anything that's remaining with your x. Anything that's being multiplied by x, you divide. Step 1, step 2, step 3. Sometimes you don't have to do these steps, and you can just check off and go right through. For instance, simplify. Let me completely hide, and I'm literally going to do it. Let me completely hide this side of the equation right here. Let's look at 3x minus 1. Can I combine like terms at all? Does 3x minus 1 equal 2x? No, it does not. That stays just as is. I'm not going to do anything there. So let's hide this side. 4x plus 8 minus x. Can I combine any like terms here? Yeah, I can combine the 4x and the negative x together. So let's go ahead and do that. So in this first problem here, I'm going to have 3x minus 1 on the left. And let me rewrite this so they're right next to each other so you kind of understand what happens. I'm putting the x on this side. So 4x minus x is 3x. And this becomes plus 8. It's kind of tricky that they gave you one of the harder problems first because this one actually will not get an x equals thing. All right, so I'm done with simplify there. Isolate. What happens now is I have x's on this side and x's on this side. And maybe this guy's saying, hey, get over here. He's like, all right. So I subtract both sides by 3x. Now there's an issue. 3x minus 3x is 0. 3x minus 3x is 0. All that's left here is negative 1 on the left and 8 on the right. And the statement now says negative 1 equals 8. Well, I didn't do any wrong math. This was the correct math, and now it has that statement. You say, well, where do I go from there? Well, here's the thing. Negative 1 doesn't equal 8. We all know that. So this is a false statement. This statement would have happened no matter what I substituted for x. If I substitute 0 for x, I'm literally going to get the statement negative 1 equals 8. If I substitute 1 for x, I'll get 3 times 1, which is 3, minus 1, which is 2. 4 times 1 is 1. 4 plus 8 is 12, minus 1 is 11. This will say 2 equals 11. Also a false statement. 11 is 9 greater than 2, just like 8 is 9 greater than negative 1. So what does this mean? What this means is no matter what you plug in for x, your right side will always be 9 greater than your left side. And that's not a true statement. These are not equal. So there's no x value that you could ever plug in that would make the right side equal the left side. This is no solution. That final statement that you say is very important, and expect something like that to be on your test, a no solution, or another case which we might run into here. As I'm looking at these problems, we will run into another one. Okay, letter B. Let's see if we can get all the way to the dividing step and actually solve for one of these guys here. Simplify. Is there anything on the left side to simplify? No. Is there anything to simplify on the right side? No. We're done with the simplifying step. Isolate. I like to try and make my x terms positive if I can, so I'm going to subtract the smaller one to this side. 5x minus 5x is 0. I have negative 10 on this side. 7x minus 5x is 2x, and I still have the negative 4. So although I got my x's all on one side, they're not alone on that side. So now that negative 4, it gots to go. Gots to go on the other side. Take the additive inverse of negative 4. That's 4. Add that to both sides there. Negative 10 plus 4 is the opposite of 10 minus 4, so that's negative 6. That equals 2x. I have fully isolated my guy right there. Now divide. X is being multiplied by 2, so divide both sides by 2. 2 divided by 2 is 1. That's what we're trying to get. X equals negative 3. Now I'm only going to do this once for one of these. How do you double check your work? What you do is you go to the original problem, because the idea is you've done math this entire time. You've done balance in your equation, and if you got it wrong, something happened in your math somewhere. So don't go to any of your math before that. Look at the original problem and see if when you substitute negative 3 in, and hopefully as you do the math correctly, you'll notice that the left side and the right side should be equal to each other. This is the only x value that should make it happen. No other x value. Like here, there was literally no x value. Here, negative 3. So let's try that. I'm going to bring this down here. Negative 10 plus 5 times negative 3 is going to be equal to 7 times negative 3 minus 4. Negative 10 plus negative 15, that's negative 10 minus 15, equals, this is negative 21 minus 4. On the left side, negative 10 minus 15 is negative 25. On the right side, negative 21 minus 4 is negative 25. Negative 25 equals to negative 25. That is a true statement, so so it checks out. It's balanced. Negative 3 worked. You try any other number and it won't work. So make sure that you're understanding of that. So that's a double checking method you can always do. Before I grade the test and you say, did I get it right? You know how you can find out? Literally double check it. Discount double check it. Letter C right here. Simplify, isolate, divide. Let's see what steps we got to do here. Do we have to simplify? Yes, looks like that left side. I have 28 and I have 4. Now I've seen this a lot. I've seen a lot of people take 28 minus and put the 4 with that, and 28 minus 4 is 24. Problem is, that minus has to do with the 6x. This is a negative 6x. This positive here with the 4 is what you're going to do. You're going to do 28 plus 4. So let's put those right next to each other, just so we avoid any confusion whatsoever. On the right side, there's nothing to combine. This will stay as 30 minus 3x. Okay, 28 plus 4 is 32. I got minus 6x equals 30 minus 3x. All right, we have simplified. Check. Now let's isolate. Now in terms of isolation, I did mention I want my x values to be positive. It doesn't matter. You can do either way, but maybe less confusing for some. I'm going to add 6x over here, so that way I'll get a positive x value. This time I'm going to do this in one step. Let's subtract that 30 over immediately. We already know we're going to move it over to the left side. So negative 3x plus 6x is positive 3x. 32 minus 30 is 2. Now I've seen this before where somebody gets a statement like this and goes, well, I can't divide 2 by 3 because I won't get an integer, so I think I'm done. But you're not done. A fraction is an okay answer. It's not unallowed. So I can divide both sides by 3. You might end up saying, well, maybe I did something wrong because I got a fraction. And that might be true. Maybe your number is really weird, right? And it gets kind of strange and you want to question your thought process and go back. That's fine. But x equals 2/3. That's your answer and that's okay. Now, I'd prefer you didn't put 0.67 repeating or 66 repeating or 0.67 because that's an approximate answer. If your number is 1/2 and you write 0.5, that's fine. 0.5 is the exact value for 1/2. But 0.66, 66, etc., even if I did 100 sixes, that's still an approximate answer. Just use the fraction. It's easier on your end. You don't have to do any extra calculation. And you could double check that. I'm not going to spend time double checking that. All right, last one, letter D here. We have, I want to get a new color. That's all right. Here we have 4x minus 1, all simplified. 9x minus 1 minus 5x, not simplified. 9x minus, this minus, not that one, minus 5x is 4x. So now I have 4x minus 1 equals 4x minus 1. You say. Now some people keep moving on. They're like, well, I'm going to subtract 4x, which you can do. It's fine. I don't care. You can subtract 4x from both sides. You're going to add 1 from both sides. You're going to get 0 equals 0. Still, Glasses guy is confused. He's like, what do I do? 0 equals 0. Well, even back up here, 4x minus 1 equals 4x minus 1. The left side equals the right side. So what does that mean? Here, the left side didn't equal the right side. It totally didn't. I had no solution. Here, the left side equals the right side. Remember what you're trying to do. Solve each equation. Solve for x. What x value makes your left and right side equal, balanced? Well, question, is there an x value I can't choose that wouldn't make this the same? The left and right side are literally the same thing. Whatever I substitute here for x, I'm going to substitute here for x. The left and right side will always be the same thing. If it's 2, if it's negative 75, if it's pi, right? If it's whatever it is, you're going to get the same thing. So what does that mean? That means x can be anything, any sort of real number. So what do you write? All real numbers. Remember, you are answering the question, what can x be? It can be any real number imaginable, and you'll get the left side to equal the right side. As you can see, the balance here is 0 equals 0. And smiley face guy, bucktooth smiley face guy, is very happy. So I've got a few more problems to go here. Find f of 4 for each function below. Let's talk about this f of stuff for just a moment. This says f of x equals. Okay. Before we saw some things that would say y equals. And you're like, how come it's now changed to this f of x thing? Why isn't it y? Well, y and f of x are the same thing, literally. Literally, they're the same thing. F of x took place of y. There's no difference. F of x is y. So how can we write that? For two reasons. F of x would literally represent a function. This has to be a function. It's the function of x is how we say it. That's one reason. So when we do it, we know we are referring to something that is a function. The second reason is because, it's just, I mean, you're going to do other reasons, like when you take pre-calc and stuff like that, you'll find reasons for why this is better. Well, not pre-calc, but calculus. You'll find reasons why it's better. It's just another way of saying, what is y when x equals blank? What is the value, what is the output, y, when x equals, and whatever number is inside there, blankety blank. Right? So that's the question that's being asked right now. And we're going to answer that. So the question for this is, what is y when x equals 4? What we're going to do is substitute 4 for x. It's a nice, clean way of doing it. And you can do a lot of different things with this. Well, I don't know how much you learned in Algebra 1, 2 for it, but you want to know what that means. So this is going to say, find y when x equals 4 for this equation. Find y when x equals 4 for this equation. Find y when x equals 4 for this equation. And then we're going to answer D. This is in addition to what you've had. I want to make sure you see this kind of problem as well. So what I'm going to do for these, f of 4, I'm just going to substitute 4 anywhere I see x. Here it's in the absolute value guy right here. So let's go ahead and continue solving for that. F of 4 equals the opposite of 4 minus 7 is negative 3, then plus 3. Absolute value means distance from 0. And because we're referring to numbers, well, on a number line, it's a one-dimensional thing. Here's 0, and numbers can only go one of two ways, positive or negative. So your distance from 0 can only literally go in those two directions. How far away is negative 3 from 0? It's 3 away. That's what your answer is. I know, you make it positive. I understand that that's what you do, but it's not literally just that. There are other reasons for which you want to know that it's not just that, especially when you move up in the math world of computing problems. So that's the absolute value of negative 3. That's 3. Now, this negative was still outside of here. So that negative still gets applied. This is the opposite of 3. So negative 3. Negative 3 plus 3 is 0. So f of 4 equals 0. In other words, 4 was your x value, 0 was your y value. This is a point on the graph, negative absolute value of x minus 7 plus 3. So make sure you understand those are just x, y values. We're not doing anything too fancy. It's just a fancy way of putting it. Okay, letter B. F of x equals x square root of x plus 12 over 4. So we're going to take the f of 4 here, remember? So f of 4 equals the square root of 4 plus 12 divided by 4. So f of 4 equals the square root of, that's 16 divided by 4. So f of 4 equals, the square root of 16 is 4 divided by 4. So f of 4, a lot of 4s. F of 4 equals 1. So there's a coordinate pair on that function that is 4, 1 for x and y. Pretty cool. And last one, letter C here. We have f of x, or f, let's just go straight through it, save some time. F of 4 equals 2 minus the cube root of 4 plus 23. So f of 4 equals 2 minus the cube root of 27. So the question for cube root is, what number do you multiply by itself 3 times to get 27? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Right? 3 times 3 is 9. 9 times 3 is 27. So that's 2 minus 3, and that's negative 1. So there's a point on this function that's for negative 1. Okay, if in part B, f of x equaled 2, let's find x. So what's the difference between this problem and these problems up here, besides 2? The difference is, now I know what f of x is. I'm substituting 2 in place of this, and I need to find x. So kind of a different thing that you're attacking here. We're now solving for x, not y. So I'm going to write 2 equals the square root of x plus 12, all divided by 4, right there. How do you solve for this? Well, this is being divided by 4, so to get that 4 out of the way, I have to multiply both sides by 4. If I multiply by 4 over here, I'm getting 4 divided by 4. That's 1. I multiply by 4 over here, I'm going to get 4 times 2, which is 8. I know you haven't practiced too much solving equations with fractions that way, but I want to make sure that you do see a problem like that. Okay, square root of x plus 12 equals 8, meaning if I had a number and I took the square root of it, I got 8. So even if you don't know what step to do next, you want to make sure you say that out loud in your head. I take the square root of a number and I get 8. What was that number? And obviously someone might say, oh, 64. How do you know it was 64? Because 64 is 8 squared. Whatever you do to one side, you have to do to the other. Now, squaring and square roots are inverses of each other. They cancel each other out. Just like when I, divide by stuff. Like check out this previous slide right here. I divided both sides by 3 because I was multiplying x by 3. I now divided this number by 3. And then I get, it cancels them out. These guys, square and square root, cancel out. So all that's left on the right side is x plus 12. 8 squared is 64. Here I have x plus 12, right? That inside number was 64. So I subtract 12 from both sides, cancels each other out. Addition and subtraction are inverses of each other. And I'm going to get x equals 52. Now this problem was not in your closure stuff, but I want you to see a problem like that for 2 reasons. 1, to see how we substituted this right here, and 2, to make sure you understood that square root inverse of each other kind of deal. All right, let's evaluate each expression. We'll go pretty quick here. Absolute values act like parentheses. You do what's inside of them first, and then you take the absolute value, and then you go from there. 3 minus 4 is negative 1. The absolute value of negative 1 is 1, so 2 divided by 1 gives you 2. That's the evaluation for A. B, once again, there's an absolute value, and once again, they also are like parentheses where I'm going to take the absolute value of negative 6, and that's 6. So what does this turn into, 116? These are like parentheses, and like parentheses, that is like multiplication. So I'm going to do 11 times 6 first. That's 66. 66 plus 15 is 81. That's the evaluation there. Okay, C, negative 19 plus the cube root of negative 8. So first thing I'm going to do is attend to this cube root part here. So the left part, negative 19, stays the same. And then I'm going to add, what's the cube root of negative 8? Now I know a couple people might be saying, we can't take the cube root of a negative number. You can. You can't take the square root of a negative number. Square root of negative 8, no good. Because here's the difference. Think of something like the square root of 16. That's 4. Because 4 times 4 is 16. You multiply the same number by itself twice. Now, negative 4 times negative 4 is also 16, by the way, just so you know. But I'm multiplying a negative by a negative, I get a positive. When you take the square root of a number, you're saying, what number do I multiply by itself with to get my number? 4 or negative 4, right? Now with the cube root, so with the square root, I can't get a negative number because when I multiply a number by itself, it will always be positive, whether it was positive or negative. A cube root, on the other hand, though, is multiplying a number by itself 3 times. So a negative times a negative times a negative equals a negative, because a negative times a negative is a positive, and a positive times a negative is a negative. So it's okay for me to take the cube root of a negative number. Make sure you understand that. So really, I already know this number is going to be negative. I have to figure out what the cube root of 8 is now, basically. And that one's 2. 2 times 2 times 2 is 8. So this becomes negative 19 minus 2, which is the opposite of which is the opposite of 19 plus 2, which is 21. So that's negative 21. Okay, last one, D. 11, negative 11, minus the square root of 16, that's 4. Negative 11 minus 4 is the opposite of 11 plus 4. So that's negative 15. Notice how I'm saying that each time. I really want you to know how to do these. Even if you use a calculator or even if you don't, I want to make sure that you know this number isn't getting closer to 0. It's getting farther away from 0. I started negative. I'm taking away from that negative, going farther out. Okay, the last one, number 90. Use the function machine shown at right to answer the following questions. So the way a function machine works is x goes in, at y or f of x comes out. So this is the input. Whatever you put into it, you get something out. That's called the output. Make sure you're very keen on that. Now for the input, I want to make sure I clarify this for sure. Whenever you put something in, you're only going to get one thing out. So when I substitute in something for x, I shouldn't get 2 answers. That's the definition of a function. So I shouldn't ever get, if I plug in 20 for x, I shouldn't get 50 and 90. I can only get one number out. It is possible in like quadratic functions when you plug in 2 different numbers for x and you get the same output. That's fine. That's still a function. Okay? But you can't split off into 2 different things. Totally making sure you understand that part. Okay. If the input is negative 8, what is the output? Meaning, if x equals negative 8, what is y? Or find f of negative 8, right? There are a lot of different ways the same question can be asked. So let's just do the last one, f of negative 8. F of negative 8 is negative 6 times negative 8 minus 3, which is negative 6 times negative 8 is positive 48, and 48 minus 3 is 45. So that's your output, 45 for that one. That's literally what it was asking. It was saying, when you bring in negative 8, what comes out? And 45 does. And again, the machine is, you put something in, it does work, something comes out. That's literally what happened. Okay, this one, if the output was 21, what was the input? So this time output was 21. That was f of x. So if f of x equaled 21, just like that last time, remember, put in 21 in place of f of x. We are solving for the input x. What came in to give us 21? So now the equation looks like 21 equals negative 6x minus 3. Add 3 to both sides. Basically solving for x. Not basically, literally solving for x. Negative 6x. Divide both sides by negative 6. Save us time. We're done. X equals negative 4. So the input was negative 4. That's what we found. Okay, so that's it and that's all. Please ask any other questions that you might have for this thing. Good luck with everything else. I hope that this was worthwhile. Fiend!